Hello everyone, it's bug fixing time. I found some bugs. So one bug is that print I arg C doesn't work. Or does it? It seems to work. Print arg 0 doesn't work. Sigfault. And the problem is simple. First of all, we don't want to do this. And here we actually don't want to do, we don't want to do this. We don't want to do that. We don't want to call Sterling. And we don't want to do that. What we want to do is also change the Sterling again, because this is not good. What we want to have is this should be here, and we should not increment EX. We should leel EX with IDE for EX, I think. And hello. Of course, we're still getting a sigfault here, but what we want to do here is leel ESP IDE into, we can do EXer as well, and then we can do move, I think it's going to be 8 into EDI, and then we can push 4 EX to get the first argument. And it's not going to work because this one is also wrong. We need to do compare this with, oh sorry, this should be move byte CL, and we should do compare byte CL. And that kind of works. Maybe I was wrong here. It should be, yeah, it should be 1, sorry. There we go, so that works. So now we're just gonna need to add this to the compiler as well. I'm wondering if this actually makes any difference. No, we can still have it there. So, but the one thing we need to change is how we do access. So this is not what we're going to do. We're going to, let's see here. We're going to move this. We're completely going to remove this. And we're going to move EBP, was it right? No, ESP. Well, actually, we're going to leel ESP EDI EX, and we're going to move, we're going to move the digit into EDI. Okay. How does this look? Now we're moving 12, but it should be 8. So there's something wrong with the offset we're doing plus 12. And now we have 0. Interesting. So the int value, that doesn't seem right. So the parser or the visitor, when we're doing I think we should just visit the, or get it from the stack. Yeah, we need to do this type of thing. And also we're setting node ID and not the int value. So wait a minute. Node int value is equal to ID. Well, it's still wrong, so but I think we can just use the stack index here. Now we're getting 12 though. Wait a minute, so the int value, we don't want to modify the int value, because that is which index of the array we're trying to access later. So actually, the offset is actually, well, actually, this access thing is sort of parsed in the wrong way. Parse ID. Yeah, this is not good. Yeah, it's actually parsed in the wrong way. We should probably fix that later. But right now, let's not care about that right now, but it could have been made a lot prettier if we separated the thing we're trying to access from. But I know I was a bit lazy when I wrote this, so I'm going to be lazy again. So we're going to, the offset is going to be the ID times 4. Now we're getting 12, and first of all, we got plus 2 here. The stack index of this thing should be, it should be 8, shouldn't it? Yeah, I know it should be 8. 4. Okay, 4, and then we just need to, oh, we're already doing times 4. Oh, we need to add 4. We need to add 4. That's why. There we go. So now we have 8. And we're leaving it. Cool. Still not going to work though. We have to change the strlen function as well. So strlen, what we wanted to do was this should be done here, and we should not increment ex. We should leave ex edi 1 cl compare byte cl. What? What's the problem? Leel. Oh, sorry. Should be moved by. And it's still not going to work because we're not pushing the value we're trying to access here. So we would be pushing push 0 ex, and still doesn't work. Is it because of this? Yeah, because this should be ESP. So, oh, actually, we were going to print 4. That was one of the problems. There we go. So, what did I do? We wanted to compare byte. And the Leel thing needs the 1 here. And now all that's left is this, I suppose. Yeah. So then we want to do push digit ex, and here we want to do the int value, so we're going to do est int value times 4. And now the problem is that we're printing 0, so we're going to change the main here to 1, because argv 0 is, well, that should work. No. Okay, so 1, that's not really what I wanted, so I think we need to add, we're going to do +1, aren't we? There we go. So 1 should give me this, right? Cool. And 3. Okay. Why? Okay, so something is really strange here. We're doing 16 EX. So 4 is the name of the program, right? And 8. And yeah, 12 should be okay. So actually, we don't want to add. We don't want to add that, but okay. So 12 didn't work. Well, is it because I didn't provide? What? Yeah, so I have to provide it. Otherwise, we're using undefined memory. But that seems all right. But the problem is that we shouldn't be able to do, or actually, okay, so in this case, argv0 is going to be the number of arguments. Which is not really what I wanted, but okay. Can we get rid of that somehow? I don't know. Maybe we'll just have to deal with that for now. Well, this is actually kind of interesting because now we can get rid of argc. And only have argv, and the first element of argv is... Well, this is kind of interesting, actually. Maybe this will become a feature of the language. I think this is better. So... 0 contains the number of arguments. So if I do print I, it doesn't really change though. Okay, weird. Oh wait, I know why it doesn't work. Because it's taking the argc into consideration here. Okay. Okay, I guess we could, for now, until I've made this prettier, For now, we're just going to do a minimum of 4. Include. No, actually, it should be a max. So, didn't work. Push 4 EX. Oh, we're still calling print. Print. Now it works. So now it works as expected. argv0 contains the name of the program, and argv1 and so on and so forth will contain the next argument, I thought. Oh wait, it's gonna be 1 times 4, so okay. One times 4. So that's not working. That works, and 0. That works. Okay, so, oh well, that works. 2. Simple. Because it's doing, should be 8. Because 2 times 4 is 8, so why is it larger than that? Oh, because I'm adding 1, of course. Okay. Cool. 1. Cool. 2. Cool. 3. Okay, so that works. Perfect. And we can still print RC, I suppose. Print I. Awesome. So we fixed that bug. Now's a perfect time for us to run our tests to see that I haven't been breaking anything. 180. And we're not going to need this one anymore. Okay. And all tests are succeeding, so great. There's one thing though that usually is problematic. And it is problematic. Now this 256 thing is broken again. What? The problem here is that we modify the strlen to move 1 byte at a time. And now we have to move 4 bytes. But that will break our code in the other situations. No, that works, but I think that's going to break things. If I run our main again, for example, well, let's just try it out, I guess. Yeah, so now that is broken. I don't really think the problem is within this one, though. It's more about well, we're not moving character by character. Oh. Yeah, here we're putting each character on their own row on the stack. And that's why we need to move 4. So that's why strlen doesn't work in this situation. So, strlen. What if we just have the strlen accept an argument for how many bytes we're going to move? So we'll do add ESP to IDI, and Now when we call strlen, Now we need to make it opposite, so this will be the 12 and this will be the 8. Yeah. So now when we call print, so 12, the second argument in this situation, or the first argument, will be the string. So I'm going to push the string and then the offset thing. Okay. Well, okay, let's do it like this. The print will not do that. The print will automatically use 1. And then the strlen will use that seems correct. Now when we do the print I, we're going to be a bit nasty, and we're going to simply copy this stuff. We actually had it this way before. And what we'll do is push 4 here. Remove those, and those. And that. Okay, I think I solved it. Let's run the tests. Okay, seems to be solved. Not in the prettiest way, but it's alright. What I want to do now is actually add this one to our tests, because this one is usually failing. Oh, that does not look good. So it's definitely not solved. I think actually the problem is that when we're printing, we're giving it a number of bytes, and when we're printing that number, it's actually occupying multiple bytes because they're on different rows on the stack. So that's the initial problem. So all the numbers gets some extra bytes here. So that looks better, right? And this one is still broken. And that is because we're comparing byte. And obviously the next byte but we're moving with 4. Yeah, the main problem is that these characters are on their own rows on a stack, so that means that they're taking up more space than they need to. So actually we would want to move that into a buffer. And that would solve this problem. Okay. So let's not do it this complicated way. And go back to how simple it was before. And I will refactor this in the next video. However, we still want to do this move byte thing. Yeah. So the strlen is obviously always going to move 1 byte at a time. That's just what it's going to do. And I'm just going to have to fix my print I thing. And we're going to implement a function that converts a number to a string instead of printing it this way. And that way this problem will also be solved. So that one will remain broken. So let's actually remove that from the test now. Since it's broken either way. Actually, we know the we can keep this file here actually, and we can format it to what we want this file to actually output, and we can do test-driven development on this thing. Let's add a test for it as well. But at least we got our argv bug fixed. And we also need to call this function, of course. Test output arith add. I have forgotten to add that one. There we can see that our variables test is failing, which is actually expected right now. So yeah. But anyway, we fixed that argv bug thing, and I'm gonna have to figure out a better way to do that int to string thing. Anyway, thank you for watching.